Hey everyone, hello and welcome to my channel, Your Physics Meet. Well, our today's video is going to be on the topic rotational dynamics and especially on rigid body dynamics. In this video, I will solve some questions which will be very helpful for those who are going to give the examination of IIT JAM, GATE, SET, CSIR NET or any other kind of competitive examinations. And I think you will find today's video helpful. And yeah, if you find so, then please don't forget to like this video, share this video with your friends, and please subscribe to my channel. And yeah, your subscriptions gives me enthuse to do more videos further. So yeah, please support me and subscribe my channel. And yeah, without a further delay, let's get started. Hey everyone, hello and welcome back to my channel, Your Physics Meet. And from the introduction, you got to know that in this video, we will discuss about some problems related to rotational dynamics and especially about rigid body dynamics. So the first problem is this one: 4 spheres, each of radius a and mass m, are placed with their centers on 4 corners of a square of side B. Find the moment of inertia of the system about any diagonal of the square. So let us draw the picture first. This one is the picture. This square has a side B, and all these spheres, these 4 spheres situated at 4 corners of the square, is of radius small a, and each of them have a mass of small m. Okay, and we need to find the moment of inertia of this system about the axis which is the diagonal of this square. That is, it may be this diagonal or it may be this diagonal. We can just choose any one of them as the axis of rotation, and then we have to find the moment of inertia of this system. So let us solve the problem. First of all, we need to know that as these spheres are solid spheres, so the moment of inertia of each sphere about an axis passing through the center of mass is 2 by 5 ma square, where m is the mass of this little spheres and a is the radius of them. Okay, so I is equal to 2 by 5 ma square is the basic moment of inertia of each of these spheres about an axis passing through the center of mass of these spheres. That is, if this one is the sphere and if this one is the axis of rotation about which it is rotating, then the moment of inertia about this axis of rotation is 2 by 5 ma square. Okay. Now we have to find the moment of inertia of the system about any diagonal of this square. That is, suppose we may take this diagonal or this one, any one of them. So if we take this one as the axis of rotation, suppose we give it a name AB. So AB is the diagonal about which we have to find the moment of inertia of the system. So how can we find that? So before just solving this problem, we need to know about parallel axis theorem. So what is parallel axis theorem? If we need to find a moment of inertia of a body, suppose this sphere, suppose the axis of rotation is this one, which is just not about the axis passing through the center of mass, but parallel to it and just going through a side of it. Okay, so how can we find this one? How can we find the moment of inertia about this axis? So we need to give or apply here the parallel axis theorem. That is, the moment of inertia about the center of mass plus m into the distance between these two axes square. That is, if the distance between these two axes is here a, because a is the radius of the sphere, then we need to give it here 2 by 5 ma square, which is the moment of inertia about the center of mass, the axis passing through the center of mass, plus m into mass into distance square, where the distance is the distance between these two parallel axes, that is this one. Okay, so we can apply this theorem in any of the bodies. Suppose I am drawing here a body, this one. This is the center of mass of this body, and the axis passing through the center of mass is this one, and the body is rotating this way. Now, if we have to find the rotation center of have to find the moment of inertia about this one axis. Okay, so how can we find that? Again, by applying parallel axis theorem. Suppose the distance between these two axes is x, then if the mass of the body is m and ICM is the moment of inertia about the center of mass, then the moment of inertia about this axis is ICM, that is the moment of inertia of the body about the axis passing through the center of mass, plus mass into the distance between these two axes, these two parallel axes square, that is xs square. Okay, so we have to apply this parallel axis theorem also here in this picture. So I am just elaborating it a little bit. So now if you have to find the moment of inertia of the system, so we need to find the moment of inertia of each of these spheres. So first of all, if we give these spheres a name, suppose this sphere is x, this sphere is y, this sphere is z, and this sphere is p. Suppose we are giving them a name. So the moment of inertia of the sphere, which is named as x, so that will be, as we have taken the axis of rotation AB, and this axis is also the axis which have passed through the center of mass of this square, of this sphere, the sphere named x. So the moment of inertia here about AB, about the diagonal AB for the sphere x will be 2 by 5 m a square, right? Similar way for the sphere z. For the sphere z also AB axis or AB diagonal is passing through the center of mass of this square. So the moment of inertia for the square z will also be 2 by 5 ma square. But for the spheres p and y, the scenario will be a little bit different. Why? Because we have to find the moment of inertia about this one axis, that is AB axis. But we cannot find it right away here. We have to find first of all the moment of inertia of this sphere. Suppose we are taking here the sphere named y. Then we have to draw a parallel axis. Parallel to which? Parallel to AB, and passing through the center of mass of this body, of this sphere y, right? So we have to draw it first. Suppose we are drawing it here, a parallel axis which is parallel to which axis? AB axis, and it is passing through the center of mass of which body? Of y, of the sphere y. So about this axis, about this green axis, okay, about this green axis, the moment of inertia of this body y or of this sphere y is 2 by 5 mr square, right? Ma square. But we need to find the moment of inertia of this sphere about an axis passing through the diagonal, that is about an axis which is the diagonal of the system, that is this one, this AB, right? we have to find the moment of inertia of this sphere y about the diagonal of this body. So what will we apply here? We will apply here also the parallel axis theorem. That is 2 by 5 ma square is the moment of inertia of this body y about an axis passing through the center of mass, plus we have to find the distance between these two axes which are parallel to each other, that is this one. And what is the distance of this portion? Suppose we give it a name. Suppose this is O and this is R. So the distance OR is just the half of the length of the diagonal. So first of all, find the value of the diagonal. What is the length of the diagonal? Just apply Pythagoras theorem. So it would be b square plus b square root over that is root 2b, right? And OR is half of the diagonal, that is we need to divide it by 2, that is half of this, that is b by root 2. B by root 2 is the length of this OR, that is this portion has a length of b by root 2. So now by applying parallel axis theorem, that is here, in case of x we need to give it, x is here b by root 2, mass m is, right, and I center of mass is here 2 by 5 ma square. So 2 by 5 ma square plus m into, in place of x we have to write b by root 2 whole square, and this one is for the sphere y, that is we can give it a name IY, right? So IY is this one. So this will be 2 by 5 ma square plus m b square by 2. This one is IY. Similar way, if this is P, then IP will also be that. That is, here we have to imagine a axis passing through the center of mass of this sphere P, and again this will be 2 by 5 ma square about this axis, and again m into this distance square will be just added with it to find the final moment of inertia about an axis which is named AB, that is the diagonal of this sphere. So finally we need to add this moment of inertia of these 4 spheres to find the moment of inertia of the whole system. That is, the moment of inertia of y is IY plus the moment of inertia of P is IP plus the moment of inertia of x is IX plus the moment of inertia of z is IZ. That is these 4 spheres y, P, x and z, right? And this is the final I, that is the final moment of inertia of this whole system. And as the moment of inertia of this sphere y and P will be the same, so IY is also equal to IP, right? This one IY and this one is IP, and they are the same. What are they? 2 by 5 ma square plus mb square by 2, and we can just multiply it by 2 because IY and IP have the same value, this one. So we are just multiplying it by 2 plus IX and IZ, IX this one and IZ this one, both of them have a same value. What is that? 2 by 5 ma square directly. So just apply 2 by 5 ma square and again multiply it by 2 because Ix and Iz have the same value. So 2 into 2 by 5 ma square for each. So what will be the final answer? Here we will get a 4 by 5 ma square plus mb square plus 4 by 5 ma square. So the final answer will be 8 by 5 ma square plus mb square. That is the final moment of inertia of the system, right? Okay, so I think it is quite clear to you. And now you have to find the moment of inertia of this system about any of the sides. That is, if this one is the axis of rotation, which one? Suppose this one. This side is the axis of rotation, or this side is the axis of rotation. Anyone take any one of this side as the axis of rotation and find the moment of inertia of the body about any of the sides. We have already find the moment of inertia of the system about any diagonal, and I am now giving you a home task to find the moment of inertia of this system about any side of this body. Okay, so just do it at your home and write the answer in the comment section. I will definitely answer your questions, and if you have any kind of questions or queries, you can ask me in the comment section below. So the next problem is, a body of radius r rolls down without slipping on an inclined plane with angle theta. If k is the radius of gyration of that sphere or of that body, then show that the coefficient of friction is given by any of these four options is correct, and we need to find that. Okay, so this kind of questions may come in the IIT JAM, CSIR NET, GATE, or any other kind of competitive examinations. So yeah, try it first yourself and then find the answer, and if you can't, then please watch this video till the end and you will find how to solve this kind of problems. Okay, so here in this picture you can see, here it is a inclined plane having an angle theta, and this body is rolling down without slipping. So this body or this sphere has a radius small r. It is given in question. Okay, a body of radius r rolls down without slipping on an inclined plane with angle theta, and k is the radius of gyration of the body. So the moment of inertia of the body will be m into k square. Why mk square? Because k is the radius of gyration of the body and we are taking the mass of the body, suppose m, then the moment of inertia of the body about the center of mass or the axis passing through the center of mass will be mk square. Now we have to find the coefficient of friction, that is mu. So here this plane has a resistive force which opposes the motion or the rolling motion of this body, and of course we know if the rolling motion, if this body is rolling down, that is the motion of this body is downwards, then the reaction or the frictional force or the resistive force will just play along this direction, that is opposite to the direction of motion of that body. Now if this body that is rolling down along the inclined plane has a normal reaction, suppose we are taking the normal reaction force as N, then the normal reaction acts along the perpendicular or the normal to the plane along which it is rolling down, and we are taking the normal reaction force as N. Okay, and if mu is the coefficient of friction, then the frictional force, if the frictional force is Fr, if the frictional force is Fr, then it will be mu n, right? Suppose we are taking frictional force as F, only F, okay? The frictional force F will be equal to mu n, right? Now, the body is rolling down along this direction, that is downwards. The mass or the weight of this body will act along this direction, right? mg, and g is the moment, acceleration due to gravity, so mg is acting along this direction. So just opposite to the reaction force, that is along this direction, what will be the component of this force or of this weight? This is the normal line which is along the normal to the plane, right? And if this angle is theta, then this angle will also be theta, right? And why it is so? If you don't know, then comment it below. I will make a separate video on this regard. Otherwise, this video will be a little elongated, right? So, if mg is acting along this direction, then the component of mg which will just make equilibria with this normal reaction will be this one, acting along this direction will be mg into cos of this angle, that is mg cos theta, and the force the component along this direction, that is this one, along the along which direction the body is rolling down, the force will be mg sin theta, right? Because this angle is theta, then this angle will be 90 minus theta, and so the component along this direction will be mg sin theta. Now this component mg sin theta will be just opposite to this component, that is mu n, which is the resistive force, and the resultant force for which the body is rolling down will be mg sin theta, that is the portion along which it is just coming downwards for this, minus this portion, that is mu n, which will resist the body to roll down. So the finally the body will come down or come rolling down for the resultant force, and if we give a result, if we can write this resistive force as F prime, right? F prime is equal to mu n. Then the force for which the body is coming downwards will act along this direction, that is the resultant force will act along this direction as the body is coming downwards, and it will be mg sin theta minus this one, this force will resist it to come down, that is mu n. Now this is the force F for which the body is rolling down. Now this resistive, this normal reaction force N will be compensated by this component of mg, that is mg cos theta. So in place of N, it will be just equal to mg cos theta, because N or the normal reaction is just compensated by this component. So in place of N, we can write mg cos theta. So mg sin theta minus mu, in place of N we can write mg cos theta. Okay. Now we can take a common of mg. So it is sin theta minus mu cos theta. Now if we need to find the acceleration, we can find it by F by m, that is force by mass, and we can find the acceleration. Suppose we are writing it as a, then the acceleration a will be g into sin theta minus mu cos theta. Suppose we are giving this equation a number 1. Okay. Now again this body is rolling down, right? As this body has a rotational motion or the body is rolling down, of course it will feel a torque inside. What will be the amount of torque? If we write the torque as tau, tau will be equal to I alpha, where alpha is the angular acceleration, I is the moment of inertia. And we already have found the moment of inertia for this body, which is that mk square, where k is the radius of gyration and it is given in the question. K is the radius of gyration. Then we can write in place of I mk square into alpha, right? Now what is the relation between alpha and A? Let us find out it first. We know alpha and A are related with the equation A is equal to R alpha. I think you know that. We know V equal to R omega, where V is the velocity, linear velocity, omega is the angular velocity. Now just differentiate it both sides and you will find that acceleration is equal to, linear acceleration will be equal to R into angular acceleration. So if you just put this equation here, A is equal to R alpha, then alpha will be A by R. So in place of this we can write, in place of tau we can write mk square into A by R. Okay. Again we know tau is equal to Fr, that is force into distance, and here the distance is of course the radius of this sphere is the distance. The force is acting along this direction, so from the axis of rotation the distance is r, right? So this distance is r is the radius of this sphere, and the force is acting along the plane, the inclined plane. So from the center of the sphere the distance of the acting force will be r, small r. So F into small r will be the tau, that is torque. So we can just equate this both, right? Which one? This one mk square into A by R, and this one F into R. They are the same because both are the values of tau, that is this one is also tau, this one is also tau, and we can equate this both tau together. That is mk square into A by R will be equal to this one F into R. Okay, so mk square A equal to F R square. Now what is A? A is this one. From this equation we already have found the value of A, that is g sin theta minus mu cos theta. So yeah, we can write the value of A here, and we have to find the value of mu firstly. Okay, in question we have to find the value of mu, and in the options we have this variables, this three variables. One is theta, other one is k, and other one is r, and nothing is there in this four equations. So which will find lastly, we have to find the value of mu in terms of these three coordinates, that is theta, k and r. So in place of, in this equation we can just write in place of A, we don't need the value of A, we just have to put the value of A here, that is g into sin theta minus mu cos theta. We can give it here. So m into k square into, in place of A we can write g into sin theta minus mu cos theta is equal to f r square. So what is f? F is this one. So f, what is f here? F is actually, we should write it here f, not f, this is f prime, right? This is f prime because we are at the force for which the body is rolling down and it is feeling the torque, that is the resistive force which is acting on this direction. This one is the f prime. So in place of f we need to write it here f prime r, that is tau will be equal to f prime r. F prime is the resistive force actually. So here we can write a f prime r square. So in place of f prime, what we can give it here? Actually this A or this acceleration comes from the force which is for which the body is rolling down, that is F, that is the final F. Okay, and this one, this torque comes from that one force for which this is rolling or this one, that is for the resistive force. So this tau will be F prime into R. So here in place of F prime, we can write this one. F prime will be equal to mu into N, and N is mg cos theta. So F prime can be written as mu into N, that is mg cos theta, mu mg cos theta. So in place of F prime, we can write mu mg cos theta into R square, right? Okay, so m k square g sin theta minus mu cos theta equal to mu mg cos theta R square. So from the both sides, m cancels out and g cancels out. So finally we need to find the value of mu. So mu is equal to this one, k square into sin theta minus mu. Sorry, we need to find the value of mu. So we need to take all the mu's together, that is just this one, k square sin theta will be equal to k square mu cos theta plus mu cos theta R square. Now mu, if we take a common of mu into cos theta from this portion into cos theta, then inside it will have a k square plus R square, right, is equal to, here we have a k square sin theta and we have to find the value of mu. So mu is equal to k square sin theta divided by cos theta into k square plus R square, that is sin theta by cos theta is tan theta, and if we take this k square just here in the lower side, we will have a value mu is equal to tan theta divided by, just taking it here just below this 2, we will have a 1 plus R square by k square, right? So this is the final answer. Mu is equal to tan theta divided by 1 plus R square by k square, which is option number this one, B, right? Tan theta is, mu is equal to tan theta divided by 1 plus R square by k square. Okay, so this one is the option number B. Okay, so that's it for today's video. I think you have find this video helpful, and if you have find so, please don't forget to like this video, share this video with your friends, and please subscribe to my channel. So okay, see you again in the next video. Till then, bye bye.